Okay, so this is the key for our percentage composition worksheet, and we're just going to kind of work through these, a few problems here and there that you can refer back to. Pretty much once I do one, you can apply the same kind of principle to the other. So be sure to show all work as shown in class, so make sure you've recorded and not recorded, watch the videos that I've recorded. You want to keep 2 decimal places in all percent composition answers, okay? And then obviously your answers will be percent of the elements. So it says write the formulas for the following compounds and determine the percent composition of each, which means each element. So nitric acid is HNO3. Ammonia we already have. We'll do some more of these here in a minute. So on this first one, I want to list my elements as if I were calculating molar mass, in which I will be calculating molar mass here. Okay, 1.01, 14.01, we get these masses from the periodic table. 3 times 16, just double check, is 48. When I add all of these up, I get a total molecular mass of 6302. Now when we find the percent composition of each element, we're going to find the percent of hydrogen, we're going to find the percent of nitrogen, and then the percent of oxygen. Okay? When finding hydrogen, we want to take the mass that hydrogen contributed to this total. So 1.01 divided by 63.02 and multiply it by 100. Same thing for nitrogen. 1401, 63.02 times 100. And then when we get to oxygen, the mistake that students make is they just put the 16, but remember there's 3 oxygen atoms, so we have to use the mass of 3 oxygen atoms, which is 48, 63.02 times 100. Now I can type all of those into my calculator. 1.01 divided by 6302 times 100. I want to keep 2 decimal places, so 1.60% hydrogen. Next one I have is 1401 divided by 6302 times 100. I get 22.23% nitrogen. And then my last one, 48 divided by 6302 times 100. I get 76.17% oxygen. Now, to check ourselves, which I don't require you to check, but it'd be a good idea on a test and so on, when I add these percentages up, since we're dealing with a percent out of 100, when I add these up, it should give me a total of 100. Sometimes you'll get like 99.99, and that's okay too. But if you've rounded everything properly, you should get 100%. I'm going to jump down to C, dealing with a hydrate, and you may need a little bit of room here, so kind of write small. Mercury 2 is Hg2+, sulfate is SO4 2-, so when I write this compound, a 2+ and a 2- cancel out, so that's the mercury 2 sulfate portion. Hexa is 6 waters. Okay, so what I like to do on these types of problems when dealing with hydrates is I just like to read left to right. So 1 mercury, 1 sulfur, 4 oxygens that come from that. When you're applying how many waters or how many of each element in the water portion, it's 6 times 2. It'd be 12 H's, and then 6 times 1 oxygen. And this is just a method that I like. Some people like to combine the total number of oxygens. That's fine. It's really up to you. Okay, grabbing our periodic table. Mercury is pretty heavy, 200.59. Sulfur is 32.07. We've got 4 times 16, 12 times 1.01, and then 6 times 16. I'm just going to add all of these up in our calculator. 200.59 plus 3207 plus 4 times 16 plus 12 times 1.01 plus 6 times 16. A pretty big molar mass of 404.78. Now, when you are finding each element. You will be combining the total number of oxygens when you get to the percent of oxygen. So, percent of mercury. Take the mass of mercury, divide it by the total. Multiply it by 100. Percent of sulfur. 3207 divided by the total mass. Multiply it by 100. Percent of oxygen. Now, I'm going to take the percent of oxygen here. Let me get a highlighter. The mass of oxygen here. And the mass of the oxygen here, because I want total amount of oxygen. Okay, so 4 times 16 plus 6 times 16 gives me a mass of 160. Okay, divided by the total times 100. And then I do need to factor in hydrogen, which I'm kind of running out of room. I apologize. Percent hydrogen is 12.12 divided by 404.78 multiplied by 100. So let's calculate each of these. 200.59 divided by 404.78 times 100 gives me 49.56% mercury. Okay, sulfur 3207 divided by 404.78 times 100. 7.92% sulfur. 160 divided by 404.78 times 100 gives me 39.53% oxygen. And then last but not least, 12.12 divided by 404.78 times 100 gives me 2.99% hydrogen. As with any problem, I want to double check to make sure that my percentages add up to 100. So 49.56 plus 7.92 plus 39.53 plus 2.99. Magic number 100. I know that I'm good.